Hello everyone, ladies and gentlemen, it's Mao Kwame Dapo, student in M1 BTP CD. I'm here to present you the document that I made to obtain my professional license diploma. So let's go to my windows to see that. Once again, I, Mao Kwame Dapo, warmly welcome you. This presentation marks an important milestone, the defense of our end of training report, produced as part of the INSTI LOCOSA professional degree in civil engineering. Thank you for being here to share this moment with us. After 3 years of training at INSTI LOCOSA to obtain our professional license diploma, I did a 3-month internship at the Portil BTP. This report details our activity during this internship on the reconstruction in total for 2 lanes of the Mississento-Alada Road. The report is divided into 3 chapters. The first chapter addresses the different structures. The second presents the work carried out and monitored. And the third focuses on the techniques and procedures used for material characterization, aggregate formulation, and field implementation of GNT. Our document follows the following outline: introduction, institutional work course, and so on. Today, the world is undergoing rapid and varied development in various fields, including the construction of road infrastructure and other technical projects. To ensure the success of this project, it is essential to set up training programs to ensure a sound design policy. That's why I did our end of training internship with Portil BTP. Let's move on to part 1, which is the presentation of the structures. Initial structure. The Institut National Supérieur de Technologie Industrielle INSTI de LOCOSA is an establishment founded in 2001 with 5 departments as follows. Geographical localization is as follows. INSTI is located in LOCOSA. As for the company, Portil BTP is an Ivorian company founded in 2012 and specializing in the construction of road infrastructure, road and various. Ladies and gentlemen, I'd now like to talk about my internship, but before I do, I'd like to briefly introduce the project. In order to facilitate transport, road, and reduce the risk of accident, the Beninese government has decided to develop and widen the RNE 2 Mississento-Alada section. The General Directorate for Infrastructure has set up the appropriate bodies to achieve its objectives, with Surat SA as delegated project manager and SET Tunisia and BCBTP as supervisor. Portil BTP is in charge of the work, with funding from the national budget. During my internship, I had to follow several geotechnical tests. Among the laboratory tests, we had to follow both white and black tests. The white tests include particle size analysis, sand equivalent, organic matter, modified Proctor test, and CBO test. The black tests include the viscosity test and the Marshall test. For in-situ tests, we had to follow the plate load test, the density test. In the rest of our presentation, we will mainly deal with tests related to the study of GNT 0315. Dear Sir and Madam, we are now going to present the result of the formulation and application of GNT as a base course. Untreated gravel is widely used in road construction, mainly as a base course. The gravel used in this project comes to the gravel binning quarry in the zoo department. So grinding curve for untreated gravel fits perfectly within the normative grinding range, indicating good particle size, distribution, and adequate homogeneity. Furthermore, the modified pressure test revealed a maximum dry density of 2.22 ton by metr cube and an optimum water content of 5 by 5.5, which ensures optimum compaction for the material. However, the CBR of 6.7 corresponding to 95% of the OPM is not sufficient to meet the recommendation required for the project base course. The company therefore opted for an agreement with CEM 2.5 hydraulic cement binder. Different cement percentage were proposed, including 1.6, 2.6, and 3. In view of the result obtained at 7 days age, Portil BTP proposed to upgrade the GNT within 2.5% cement. The principle being to keep the material flexible despite the fact that the material improved with 2.5%. Cement has a CBR of 208 more than 130. The choice of this dosage is justified by the fact that the other mechanical characteristics of the material give it flexible characters, while the dosage of 1.5% and 2.0% cement, leading respectively to 7 days compressive strength of 19.9 and 21 bar, are barely equal to or higher than the required minimum strength of 20 bar, which could lead to lower mechanical performance when the hazard of on-site provided are taken into adjustment of spreader metering devices, guts of wind. The GNT is previously supplied spreader and preset in 3.5 cm thick layer. If the spreader is not available, we proceed with marking auto-selected mesh dimension, placing the cement package in the well-marked meshes on the ground, cracking the cement packs with careful removal of the papers, and spreading the cement using manual scrapers. If the spreader is available, set up the spreader and spread the cement at a rate of 16.90 kg by metr square. After spreading the cement, the recycler coupled to water tank mixes the material. The water content of the mixed material was constantly monitored behind the recycler so that any necessary adjustment could be made. After the recycler had passed through, the material is adjusted and compacted according to the sequence defined below. Two pairs of the tire compactor just behind the recycler. After mixing 2 times 10 the material and maintain the water content. Pre-adjustment followed by final adjustment with the grader and compaction. After laying the GNT base course, the company carried out a verification test in the presence of the inspection team. The density test is an in-situ test to determine the dry density of the layer in order to assess its degree of compaction. The CTDP requirement for the in-situ density test is a compactness greater than 97% of the OPM. In our case, we have 100% of values above the 97% of OPM. This is therefore a good implementation. The deflection test is an in-situ test used to measure the structural rigidity to resist a rolling load. To determine at each kilometer's profile the vertical displacement of the point on the surface generated by a rolling load on the ground. In our case, we found a characteristic deflection of 56, which is less than 6.5, which complies with the specification. This training course on the Alada-Mississento Road reconstruction site was a very enriching learning experience and helped us understand that theory don't apply so easily on site, hence the need for practice at the end of the course. Thank you very much for the attention throughout this presentation. Your feedback and suggestions are most welcome to help me progress. Ayan, 18 minutes.